And our next innovation and company is FlyScan, and we have Eric to do his presentation live.
Thank
So
you.
Go ahead, Eric.
So you see the PowerPoint now?
We can, yeah.
All right. So my name is Eric Bergeron. I'm the founder of FlyScan, and we are active in the midstream space. For those who know pipelines, there's something called a pig. So those pigs, they go inside the pipe and they check for defects on the metal. They check everything inside the pipe. So what we do is a flying pig. So we check everything around the pipeline and above on the right of way. So the company was started in 2015. We are a spin-off from a research lab called INO, which is Canada's largest R&D establishment in laser technology. Initially, we got funding from PHMSA. So the US DOT, PHMSA gave $500,000 to INO to check if it was feasible to detect small leaks, so 1 barrel per day for a liquid pipeline. So we don't do methane. A lot of companies are already going after methane detection. So we are focusing on crude oil and refined products. So that's our niche in the market. Since inception, I raised about $11 million of funding to develop the product, USD, and now we have something that will start to fly this year. Last year, we were very happy to get an equity investment from Enbridge. So Enbridge is the largest pipeline operator in the world. So for us, it was very important to have them on board as a validator, as a sign that the market is there, that pipeline companies will buy that and need that. So and they are also a great partner for development. So they not only contribute money and sales, but also contribute brain power to develop software with us. We also have an investment from BDC, which has the second largest clean tech fund in the world. So our mission is twofold. First of all, to catch slow leaks early, so to minimize the cost of cleanup. And second thing is to find everything that can cause a leak. So any sign of activity on the right of way, so machinery about to dig or damage the pipeline, geological risks, overgrowth of vegetation, exposure of the pipeline if there's a serious event of weather. So everything that causes a leak or any sign of a present leak from an underground pipeline. So that's what we are doing with our flying pig. An example of a small leak that was a complete catastrophe. So that's one of the customers we met in the US. They had a leak in North Dakota. It was caused by a lightning strike that punched a very neat hole, 1/4 of an inch. It leaked for at 800 barrels per day for a month. The SCADA-based system never picked it up, and they flew 4 times over it with the air patrol, the weekly patrol. They never saw anything. It was the farmer who found the leak. So just an example that a small leak can become a big disaster very quickly. So how do we do it? First of all, we had a sensor. We have a remote sensor, I will explain, that detects benzene. So we use benzene as a tracer for crude oil through the ground. Then we have a set of cameras that look down on the right of way. And with software, our goal is to automate everything which is done today by a human observer. So observers can become distracted, they can become tired. Those flights can be long and boring. So the software is never bothered, never tired. And the goal is to automate everything which is done today by eyeball detection. So on the ground testing at 500 feet, which is our altitude of flight, with a measurement time that was equivalent to the exposure time we have during the flight. So we were able to detect 1 cup of crude oil. So we detect the oil when it gets close to the surface, it mixes with soil, and then benzene starts to evaporate, and this is when we detect it. But so I think in terms of benchmarking, I don't think any satellite company could run 1 cup of oil from space while we can. Another example, this is to show you the kind of data overload that pilots can live when they fly over a right of way. So we flew over a dealer of machinery. So this was all real time. So the software picked up all the machines, identified them properly, located them, and then we can send a real-time alert to a control center. So once again, the goal is not that the pilots are bad observers, it's just that they also have to fly safely the plane, and our software can make it much easier and much safer. And sometimes those threats are hard to pick up. So this is an example. I was myself on board. It was in December last year, a dull gray day at 3 p.m. Sometimes you can miss machinery that's in the right of way. So here you see some farming equipment. I never saw that, but software picked it up after the flight when we processed it offline. So how do we do it? For the oil detection, we detect benzene. So benzene is not supposed to be found in nature. So if you detect benzene in the right of way, there's a problem. And it's a very, very good tracer because it degrades quickly. So if you detect benzene, it's not a leak of last year or pollution from last month. It's a live leak from fresh oil. And we can detect part per billion, so very, very small traces of benzene. And we do it with a custom-made ultraviolet laser that is tuned to detect specifically the benzene molecules. When we offer that to pipeline companies, it's a bit like selling insurance. So the financial business case is based on avoidance of remediation. So there's a cost to fly, but there's a value of all those barrels of oil that you don't need to clean up the mess after. So those two curves intersect, and there's a positive business case to fly the pipeline with our system less than once every 2 weeks or every week. As I mentioned, we also automate the visual inspection. So the goal is to replace eventually what the human is doing to comply with regulation. So it goes from encroachment in the right of way to soil movement, landslides, any kind of anomalies in vegetation, exposure of the pipeline, dead animals, missing markers. So the pilots, they have a laundry list of stuff they need to look for. I mean, no human can do that and fly safely at the same time. So the goal is to help everybody. And that software for threat detection, so right-of-way inspection, is developed by Enbridge. So they have an innovation lab in Calgary and Houston. So they're developing that as an in-kind contribution to our product. So they have a great team there. So they develop the requirement, and they also develop the testing with us. So there's a nice tool that after a mission, anybody in an office could go look and relive, if you will, the air patrol and see what was detected, the exactly located. So again, as a summary, we automate the visual inspection of the right-of-way, we detect oil presence, and we give a completely geo-referenced documented report of all that. That's it. Thank you.
Okay, thank you very much, Eric. Well done.